But the definition of an inverse, if we're not even talking about an inverse function, is just when you switch the ordered pair around. So it says the ordered pair AB is in a relation if and only if the pair BA is in the inverse relation. And so that's an easy way to remember inverses, is the x and the y switch places. And so if we're talking about the x and the y switching places, we could actually go ahead and say that the domain and the range, every x becomes a y, every y becomes an x. And that's how we find inverses. That's helpful when we're graphing inverses. And so just like we have the vertical line test helps us determine if something's a function. We also have a little test that we can figure out if a function's inverse will also be a function. And it's really similar to the vertical line test.
You ever have dreams where you like wake up and you're like, oh my god, that was a dream?
I have really weird dreams lately.
Right after that.
I've been having dreams, this is the first time ever. I've been having dreams where I think I'm awake, but I'm still in my dream. Like I wake up from my dream. Like I had a dream that I woke up from my dream, which was really weird, and I woke my husband up to tell him how crazy my dream was. But then I checked my Facebook, and what I dreamed was really on Facebook. But I was really still dreaming the whole time. And so then I really woke up, and I was like, oh my gosh, that was like Inception or something, like levels of dreams. Like I've never done that before in my life, but
I do it all the time.
it was crazy.
Like I think I wake up and get fixing a dress. I'm actually not. I told my mom I wake up in Newcastle, but I really want to Indianapolis. She kept telling me, she's like, where are you at?
Sounds like you have a guilty conscience.
Why are you home? Why are you home? I'm on my way. I'll be there in 5 minutes. But I was still in Indianapolis. And I woke up and I was like, oh man, I gotta see my mom home.
All right, so vertical line test is how you can tell if something's a function. If every vertical line only touches the graph in one spot. Well, for inverses, we have the horizontal line test. And it says the inverse of a relation is a function if and only if each horizontal line intersects the graph at only one point. And I'm going to draw some little graphs on here in a second, but I'll let you write that down first.
Honestly, can you make a math science every
No.
simple, but effective?
No.
It was. I learned what I needed to learn.
You learn the most. Here's the thing. You don't learn when it's just like basic level like problems and you don't have to think any. You learn the most when you get to a problem and you have to think for yourself and work through the problem.
I had to think through problems, but they weren't like ridiculous, like.
And that's what problem solving is. Problem solving is looking at a problem and having to figure out how to do it. Just plugging in numbers and getting out the answers. That's a boring problem to me.
We're not all as mathematically inclined.
Well, I'm trying to prepare you for college, so
Surely got a 2.
unfortunately. Oh, you know when I took the exam in high school?
No.
Yes, when I took the exam in high school, I only got a 2 on it.
I don't know. It's not what it is.
You need to call her right now. She's on prep.
Call her right now.
No, I don't
She
want.
won't.
I
I
don't
want.
want.
She knows.
I got a 2 on the AP Bio exam. I bet that's what she told you.
She said she got a 2 in 85.
She didn't take AP Bio. She's too old.
Oh yeah, she did say that.
That's what she always says at lunch. She acts like she's like 20 years older than the rest of us. She's always like, I'm so old, we didn't have cell phones. I'm so old, we didn't take AP tests. I'm like, you're really not that much older than us.
5 years.
Not even 5 years. So, I don't think.
Just a drastic change in education technology.
I know, it did happen very quickly. I think I was the first class that took AP at my high school. Maybe the second. It was, yeah, I didn't do very well. But it takes a while to get a good AP program going.
One day I'll be like, yeah, I was the first class to take ECA.
No one will even know what ECA is by then because it's changing. 2015, it's changing to PARCC, P-A-R-C-C.
Is that straight line?
It's kind of like a curvy line.
ECA is honestly worthless. I don't even know why they do it.
Logan, you think everything in school is worthless, so I don't know why we have these discussions.
This class is brilliant. These
examples here of graphs. When we're trying to see if something's a function, we draw vertical lines because we're looking for all the x values to be different, right? That's the definition of a function, is that x can't repeat itself. Well, to tell if a function's inverse is also a function, you have to check horizontally, because when you check horizontal lines, what are you actually checking to see if there's only one of the y value? And why would we want to know that the y values only have one value for each line when we're talking about the inverse? Because what happens to the range for the inverse? It becomes your domain. So when you're checking horizontally, you're basically checking that when you do the inverse, that it would also pass the vertical line test. I don't know if that's way too confusing, but that's what we're looking for here. So it's really easy to do, just like the vertical line test. If I draw a horizontal line through here, each horizontal line could only touch that graph in one spot. If it touches in more than one spot, then it fails the horizontal line test, which means this graph's function is, this graph's inverse is not a function. So I'm going to write that. Inverse is not a function. Because it would have those x values would repeat themselves if we turned it over. The middle one, no matter how we drew some horizontal lines in here, each horizontal line is only going to touch that graph in one spot, which means if we flip the domain and range, this would pass the test of being a function. So we're going to say yes, inverse is a function. I think there might even be some on your homework where they just give you the graph and you get to say yes or no if the inverse is function. And what about a quadratic? Yeah, that's a problem. And if you think about, we've dealt with this before. When we talk about the inverse of a quadratic, we talk about a square root function, but we only graph half of it because that's what makes it be a function. So this one is no.
You think of it this way. Right there's your parabola. If you take the inverse of a parabola, wouldn't it just be like facing?
It would be a sideways parabola,
Yeah.
which means it would fail the vertical line test. Right. Yes, and that's what the horizontal line test does. It just makes you not have to like visualize flipping it, because sometimes it's hard to visualize flipping
When I
it.
think of a plane, I think of like a graphing plane. I think of like east, west, north, south. I don't know why. Going west, 2 spots.
I don't know. I'm not good with direction, so I don't think that way, I guess. Mr. Baines always good with direction. He always like, go out the north entrance, or if you go out the east entrance, and sometimes he says we're going to have a fire drill where he says the east entrance is closed, and I'm like, I hope you give us a number, because I really don't know. If I really think about it, I can think about, like, I think about 231, so I can figure it out, if I know where I am.
Where the sunrise would be.
Where else? That way. But there's more than one east entrance, right? We talked about this last year. I'm sure you remember because it was just one day that we talked about it. But a one-to-one function, you definitely need to kind of know that word. A one-to-one function is a function that passes both the vertical line test and the horizontal line test. That means that if it passes the vertical line test, it is a function. And if it passes the horizontal line test, that means its inverse is also a function. Inverse a function. It also means that no x repeats itself and no y repeats itself. Right? If you drew vertical lines, all of them would only touch in one spot, which means all the x's are different. If you drew horizontal lines, all the y's would be different. So one-to-one function, every x is matched to exactly one y. That could be a vocab word on your test. Define one-to-one function. Write an essay about one-to-one functions. Just kidding. No essays. Not yet. Okay, so let's get to the good stuff, the algebra, right? So the big thing is we want to be able to prove that two equations are inverses of each other. And the way that we can do that is by using composition. Is everyone okay if I go to the next slide here? Oh, no. Inverse functions. their compositions will give you back the identity function. Maybe we should write that out. I don't even know how to write it. We'll just write the notation here. Remember the way that we write inverse functions? Maybe I'll write that up here. F negative 1 of x. We don't say that's f to the negative 1 power. That's read as f inverse. So if you take a function and it's inverse and you do the composition, like the f of g of x stuff, you will always get back the identity function, which is just x. Yeah. So it's like, I could write it like this if you want, like a little circle. F of f inverse of x, if you prefer. I like parentheses better. But if you take the inverse function and you plug it into the function, you're going to get back x. And if you do it the other way, if you take the function and you plug it into the inverse function, f inverse of f of x, you're always going to get back the identity function. Because if you take a function and you put it into its inverse function, it's basically like it undoes everything. And so when I ask you, or when the book asks you to show algebraically, a lot of people like to just pick numbers and show that, like if you plug 1 in and you get 3, you can flip it around and you get the other one out. That shows that it flips the x and the y for 1 point. To show that it works for every point, you have to do this composition. And this is what I'm going to expect you to do on the homework and when we have a test. So we're just going to do some examples of this. I don't know why that's in bold, but are the two functions inverses of each other? Show algebraically. That means if you just write yes or no, you're not going to get credit for that. I want to see the work there. No. No. So they just give us two functions, f of x and g of x, and we're just going to do that composition to see if you get x back. If you don't get it back when you do it the first way, there's no need to do the other way, because if it doesn't equal x the first time, obviously it's not going to work. But you do have to do it both times. So if f of g of x equals x, we also have to check the other one. So you have to show that it works for both of them. And that's kind of what we're used to more than the inverse stuff. So what I'm looking for is, do I get x back? So hopefully we're feeling pretty good about this. I'm going to take the g of x function, which is 1/3 x plus 2, and I'm going to plug that into the f of x function, which means everywhere I see an x, I'm going to replace it with 1/3 x plus 2. Sometimes you can kind of see right away if some stuff's going to work out. If you don't get x back, then it's not going to be a good thing. But I think I'm going to get 3 times 1/3 x plus 2, and then I have that minus 2. All I've done is taken g of x and plugged it into f of x. Yes, sir. Where's what? Why did I have this? Because all I did first, like I always start with the inside, I just replaced g of x with what g of x equals. So then I'm doing f of that, which means I'm taking this and plugging it into the f function. You don't have to show that step if you don't want to. I just like to, I don't know, that's just how I always do it. Other questions about where that's coming from? 3 times 1/3 is just 1x. 3 times 2 is 6 minus 2. Is that going to give me, it's not. And a lot of times people try to just tell by looking. Like they're like, oh, 3 and 1/3 plus 2 minus 2, it works out nicely. But this does not give me x. It actually gives me x plus 4. So since I didn't get back the identity function, I don't even have to check the other side, g of f of x. It doesn't matter what that equals. This did not equal x, which means I can say, no, they are not inverses. What? Because if they're inverses, you're just going to get x back each time, like every time. You're going to get back the identity function, because inverses, think about the inverse of adding is subtracting. The inverse of multiplying is dividing. The inverse of squaring something is square rooting something. Inverses undo each other. So if two functions are inverses of each other, you're going to get back just x when you're done because it's going to undo everything. So let's do one more of these. You do this one. So f of x is 1/4 x minus 3. G of x is 12 plus 4x. I want you to do f of g of x and see what you get. And if it works, you also need to do g of f of x and see if you get x back. So take a minute and make sure that you can work that out. On the test, I'm definitely looking for yes or no, but you got to have some work to go with it, and so that's what I'm looking for also. You should get that when you plug that in, it works out nicely that we get x back for f of g of x, we get x back for g of f of x. So are they inverses? Yes, they're inverses, but you got to have the work algebraically to support it. Questions about that? Definitely the composition is important to make sure you know how to do that. No, not yet. A couple more things. But it's still not new stuff. We've done it before. So, any vague memories of this? I'm pretty glad we just learned all new stuff so that I stop asking if you remember things. Graphing. Your favorite thing. I think maybe, if I remember correctly, that, I don't know, you don't have that much graphing on your homework.
So we don't actually have to solve secret inverses, these will all be.
Right, this one says graph the two functions, and these are actually inverse functions. Might have to do it at some point, but this one is just an example of two functions that are inverses. And I just want to graph both of them just to show you the properties of inverse functions when you're graphing them. It is just going to be a linear line. Hopefully it's a pretty easy line to graph. If I graph 2x plus 4, we just start with the y-intercept, right? You definitely need to know how to graph, yes. Well, I could ask you to graph something else too. Right, we have 10 basic functions. I really could ask you to graph any of them. So if I graph this, I'm going to start with my y-intercept, which is 4. And I have a slope of 2, which means I could go up 2 over 1, down 2, back 1. Right, and I get a really nice little linear equation. The same thing for the 1/2 x minus 2. If I graph that, I have a y-intercept of -2 and a slope of 1/2. So I'm going to go up 1 over 2 or down 1 back 2. Inverses always have a symmetric quality because the definition of inverse is the domain of the range switch. So first of all, if you ever have to graph a function that's inverse, really all you got to do is graph 1, and then you can just switch the points. And just to kind of show you here, what would be the ordered pair for this point right here? -2, 0. So if you switch those around, look what point's right here. 0, -2. Right? Every single point, they switch places. This is the point 0, 4. This is the point 4, 0. Right? They're symmetric about this line right here, like cutting right through the first quadrant and the third quadrant. This is the line y equals x, and inverses will always be symmetric about that line. So you can like imagine taking this and flipping it over this line, and that's how you get that. That's why a parabola x squared, when you flip it over, you get a parabola on its side because it just flips over that line there. So think about that when you're doing your inverses today, or when you're graphing. That's something nice to think about there. Okay, so always symmetric about that line. Questions about that? Last thing we're doing, finding inverses. Last year in Algebra 2, I gave you all these steps to find an inverse. Like I said, like step 1, replace f of x with y. Step 2, switch x and y. Step 3, solve back for y. And then replace it with the inverse symbol. But basically, all you're doing to find the inverse is the definition. The definition is you switch the x and the y around, and you get y back by itself, and that will always give you the inverse. I think I need to do some spacing on this. For some reason, every time I save this now, it just squishes them together. So we're just going to practice. A nice linear one, and then one that's not so linear. And definitely on your homework today, different from what we did in Algebra 2 last year, is you're not just going to see linear equations because we have dealt with so many other things that we should know how to find the inverse of a quadratic or of we're getting there. I said we're going to start with a linear one and then do a harder one. So you guys swap the x and the y. Remember that f of x is the same as y. So if I switch these two around, first of all, if you want to write that as y equals 5x minus 7, you can. But f of x and y are exactly the same. So the definition is they switch places. So x equals 5y minus 7. And then you just get y by itself. Like your steps are switch x and y, solve back for y. In a linear equation, I hope that's really easy to do. I'm going to add 7. And I'm going to divide by 5. It's really up to you how you write this. I always think about if I was graphing this, how would I write it? I wouldn't leave it as x plus 7 over 5. But I'm not going to mark it wrong if you do. I'm going to write that as 1/5 x plus 7/5. Because I think about slope-intercept form when I'm thinking of linear equations. The last thing that I want you to do is use the notation, right? If this is the inverse of f of x, I'm going to say f inverse of x equals 1/5 x plus 7/5, or x plus 7 over 5. When I do that. Questions about finding the inverse of a linear function? It's going to work the same thing for everything. You should be able to find the inverse of anything as long as you know how to undo that. Here's an example of a polynomial function. So go ahead and switch the x and the y. process of getting y by itself, and you're probably not going to, you think it's going to be hard, but just think about what would you do to get y by itself? Well, we want to get y by itself first. So even if you're, like the whole idea is over here we're getting y by itself, we're still getting y by itself. So before you start dealing with that cube, I think we could get rid of the 1 and the negative, right? Like I'm going to subtract 1 and get x minus 1 equals negative y cubed. I'm even going to go ahead and get rid of that negative, so I'm just going to kind of divide through or multiply through by a negative, which means that would make that negative x plus 1, but I'm going to turn around and make it 1 minus x just so it looks prettier, but it's okay if you wrote negative x plus 1. The difference between these two problems is this is not linear, so we have to get rid of this cube, and I think Logan said it already. The way that you undo cubing something is you take the cube root of it. That became a negative and that became a positive, right? Like I divided by a negative, so that changed the sign of everything. And since instead of having negative x plus 1, I just thought it looks nicer to have 1 minus x, but it's really the same thing, right? You can write it in any order that you want. I just did that because I always think it looks not very nice to have a negative underneath a radical sign. It just makes me feel wrong. And so I get y equals the cube root of 1 minus x. Are you allowed to separate addition and subtraction under a radical sign? Never. So you cannot do anything with that. I also want to point out, you might think we should put a plus or a minus here. That's only if it's an even root. Like when we do a square root, the reason we put a plus or a minus is because negative 2 squared is the same as positive 2 squared. But if it's an odd root, it's not the same, right? If you take negative 2 cubed, you get negative 8. If you take 2 cubed, you get positive 8. So you don't have to worry about that there could be two possible answers because odd roots can be negative, even roots can't be. So you don't put a plus or a minus there. But the inverse of a cubic equation is a cube root equation. And so this would be my inverse. So if you see something on your homework that's not linear, don't just say, oh, that's too hard, I don't want to try it. Just go through the steps, and you'll probably get to the point that you're like, oh, maybe I could just cube root it. Maybe I could just square root it. Like, just think about how you can undo it. Questions about that? I don't think this is such a bad day, is it? Definitely more than 6 problems. Precalculus. It's supposed to be difficult. So here's your homework. This is 5-1 day 2, which is on your assignment sheet. 9 through 12 all, 15 through 33, multiples of 3. Sorry. You're right, we're not on chapter 5. Sometimes I get confused. 1-5. Thanks. 15 through 33, multiples of 3, 43, and 44. And you do have a few minutes to work, so get started on this in case you need some help. And I'm going to get some papers for the thing. not tomorrow. You don't have this one. Like when we get through all this, we'll review and we'll have a test over everything. And since we just moved in, this we'll talk to them. So you don't remember all the problems. We'll figure it out as it goes. But I wanted to just point out that this my conversation with me like every third problem. So like you don't all 15, 18, 21. Does that make sense? Because some people do all of them. So yeah, you just need to do this tonight, and we'll go over it tomorrow, and we'll get more stuff. Like we'll do this tomorrow, and we'll just go, and we'll have a test. So probably next week we'll have a test, and like I said, we'll see how you are. So we'll decide to okay, but just let me know if you have a question or if you feel like you're getting lost. Okay? I think so. You're a genius. Is it a function of vertical? And this one's always right? So I think that you have to, because your y is on the bottom, I think you have to do this a little bit of Let's look at number 15. So Logan, what does number 15 say?
fx equals 2x minus 3 over x plus 1.
So, on this problem, when you switch stuff around, you get x equals 2y minus 3 over y plus 1. And you definitely have to use some algebra skills to get this solved back for y, because we have a y in the numerator and a y in the denominator. The first thing that we need to do is we need to get this denominator, like, we don't want a fraction in this. So think about, it's an equation. Would I be allowed to multiply both sides by y plus 1? Would that cancel that y plus 1 out there? Just like if there was a 3 on the bottom, you could multiply both sides by 3, and that cancels out your 3 in your fraction. So that gets me a little better, at least gets rid of my fraction. And I'm just going to distribute this x to both of these. So I get x times y plus x equals 2y minus 3. With me to there? I want to get y by itself. Since I have two things with y in it, does it make sense that maybe we should put the y's stuff together on one side and everything without a y on the other side? So it doesn't matter which way you do it, it's going to work out the same. But I'm just going to subtract 2y over here, and I'm going to subtract x over to the other side. So everything with the y is going to go on one side, everything without a y is going to go on the other side.
What if you already had x plus 1, or xy plus x plus 3 equals 2y, then couldn't you just...
You can do it the other way, yes. Yes, as long as you get the y's on one side and the other stuff on the other side, it doesn't matter if your negative signs are a little different, because it's going to work out the same way. I'm going to be left here with xy minus 2y. Notice I can't put these together. One has an x in it, one doesn't. And over on this side, I have negative 3 minus x. It's going to be a little different if you have stuff on the other side. Now here's where we got to think algebraically. What could I do to separate this y from the x and from the 2? Yeah, I could just factor out a y. Just like if we want to factor out an x, there's a y in both of these. Could I factor that y out? And then I would just be left with x minus 2. Or 2 minus x. And now this is y times all this. So what am I going to do to get y by itself? Divide that over. And again, your negatives on the top and the bottom might be a little different, but it should work out to be something like negative 3 minus x over x minus 2. If your stuff on the top is positive, then that means your other way it might be 2 minus x on the bottom. Like, do you have x plus 3?
Plus 3 on the top, negative x plus 3 on the bottom.
And that just means your negative is in a different spot. Like, my negative's on the top, your negative's on the bottom. It still means the exact same thing. But that's some good algebra. Like, that probably could show up again, being able to separate an equation like that, of knowing that, oh, get my y's together and think through that problem. But there you go. I just did a homework problem for you. Both of them are the answers, whichever way you did the problem. Both of these are the same thing, right? Like, I could take a negative out of the top of mine. That means the same thing too. Like, it's just, I mean, because the negative could be anywhere you want it to be, there's lots of different ways of writing the same thing, which is so much fun to create.
Do we have to give the same range?
Does it say give the domain range? No, that's okay. You don't have to give the domain on those. When you're done, you don't have to give the domain on those problems that you find the inverse of. You could, like, you could look at this equation and tell me what x couldn't be, but it's fine. If you want some practice with domain, you might want to do that. I've totally been recording this whole time.